So we're going to begin by talking about the fundamental counting principle, and we're going to lead that into permutations, combinations, and ultimately into binomial theorem. So we're going to talk about basically ways to count things in terms of figuring out how many different possibilities there are for doing something. All right. Then it starts with the fundamental counting principle, and the fundamental counting principle says this. If you have one task, so one thing you want to do, and it can be formed A ways, that's not an A, it's an A. In other words, it could be 5 ways, it could be 6 ways, but if there's a certain number of ways that it can be performed, and then you have a second task that can be performed B ways, that is another set number of ways, then the two can be performed together in A times B ways. That's the fundamental counting principle. So essentially what that means is if I can pick from a deck of cards and I can roll a die. The deck of cards has 52 possible cards in it. The die has 6 possible faces. So the number of ways that I can do that, the number of different ways that I can, or different combinations that I can get, are 52 times 6. So I can pull each card and then roll a 1, pull each card and roll a 2, pull each card, roll a 3, and so on. So that's the concept of the fundamental counting principle. All right. So what we're going to do is we're just going to look at a couple of different examples of that. The first one is from the textbook, and it's on page 517. You can see here that it says a store manager has selected 4 possible applicants for 2 different positions at the department store. And how many ways can the manager fill the positions? So what we have to think about is, first of all, 2 different positions. Okay, so we put 2 spaces down. And what we do is we say, okay, the first spot can be filled how many ways? So we have 4 possible applicants, so the first spot can be filled 4 ways. And then, because there's 4 possible applicants and we filled one of them in here, there are 3 left. So the second possibility is 3. There are 3 different people left to fill that position. And then you multiply them together and you say there's 12 ways that you can fill those 2 positions. Okay? And that's the fundamental counting principle. All right? Now, look at part B. Part B says, in how many ways can a teacher seat 4 girls and 3 boys in a row of 7 seats if a boy must be seated at each end of the row? So you've got 4 girls, you've got 3 boys, all right, in a row of 7 seats. So what you do, don't look for a second here, we're going to erase this. And we're going to put 7 seats down. So here's my first seat, 1, 2, 3, 4th, 5th, 6th, and 7th seat. Now it says that it has to start with a boy. All right, so we look at this for a second. We say, how many boys are there? There are 3 boys, it says. So I have 3 options for that seat. And then it says the other stipulation is that it has to end with a boy. Okay, so we have 2 possibilities down here for a boy. All right, and then in the middle seat, we have 4 girls and we have 1 boy left, right? So that means we have 5 positions to fill and 5 people to fill them with. So we can go 5 and then 4, 3, 2, and finally there's only 1 person left at the end. So we have this. And we just multiply all of this together. Okay? That's what the fundamental counting principle says we can do. So the only thing about the fundamental counting principle that you have to be careful of is that you have to be careful of any stipulations it gives you, all right, or any restrictions it gives you to what you're doing. So if you think about this one, because we had to put a boy in the front and the back, we had to limit our possibilities to 3 and then 2, and then everything else works as you see it there. So then we just multiply it out. So we have 3 times 5, that's 15. 15 times 4 is 60. 60 times 3 is 180. You double 180, you get 360. If you times that by 1, you still have 360. If you times that by 2, you end up with 720 different ways that you can fill those seats. Okay, so that's the fundamental counting principle, and that's the premise behind it. All right. Now, what we have to understand about the fundamental counting principle, is that it makes use of what is known as a factorial. And a factorial is simply a shorthand way of writing 5 times 4 times 3 times 2 times 1, etc. So it's a product, the factorial, the definition of factorial is the product of all of the positive integers preceding and including the number you are taking the factorial of. Now, that may not make a whole lot of sense in terms of the words, but it means that if I want 5 factorial, it's 5 times 4 times 3 times 2 times 1. Okay, if I want 6 factorial, it's 6 times 5 times 4 times 3 times 2 times 1. Okay, and the reason it uses factorials, if you jump back here for a second, you can kind of see why that might be helpful, because if you look at this, that's 5 times 4 times 3 times 2 times 1. So that's actually just 5 factorial. Okay, and we denote it with an exclamation point. So you'll see on your calculator, if you look, that it has that exclamation point. That's what it means. It's going to take 5 exclamation point means 5 times 4 times 3 times 2 times 1. Okay, so we're going to use factorials as we count. Okay, so the notation is n factorial. That means any number factorial. So there's our 5 factorial. And then in order to actually figure what it equals, you can just type it into your calculator, see if it tells you it's 120. It should. But if you're not sure, it's just 5 times 4 times 3 times 2 times 1. So 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. Times 1 is still 120. So that's the idea behind a factorial. Okay. And there are 2 types of counting based off of the fundamental counting principle. One is what we call a permutation. And the idea behind a permutation is that we're going to order a sequence, we're going to order arrangements, and in order to do that, we're going to figure out how many ways can I do that based on a couple of parameters. And the parameters are n and r. N is the number of possible selections. So n is, we're picking from a group of 20, let's say. And r is the number of positions that we're actually trying to fill. So we might say I want to pick 20 from 20, but I only want to pick 5 of them. Okay? So that's what a permutation does. And the formula is n factorial over n minus r factorial, where n belongs to the natural numbers. That is, it's 1 or 2 or 3 or 4 or 5 or so on. Okay? So if I want to take from 20 and I want to pick 5, then the formula would be 20 permute 5. And you will see that on your calculator somewhere. You don't always have to use the formula, but what it would become then is n factorial, so 20 factorial on the top, and then divided by 20 minus 5 factorial on the bottom. Okay? And what happens with that is you end up with 20 factorial on the top, and on the bottom, you end up with, just to finish this before we get into an example, 15 factorial. Okay? And to simplify that, what we're going to do, I'm going to jump over here because I need a little more space. But 20 factorial is 20 times 19 times 18 times 17 times 16 and then times 15 all the way down, right? So this is actually just going to be 15 factorial because it's 15 times 14 times 13 if we kept going. But on the bottom of this is 15 factorial. So what ends up happening is these divide out. They become 1, all right? And the answer is just whatever 20 times 19 times 18 times 17 times 16 is. Okay, and I'm not going to do that right now. It's a big number, but you can do that on your own. But the idea behind a permutation, in terms of how do you know that something, when we're counting, the fundamental counting principle says if you can do it A ways and B ways, then this is, but a permutation is a special case of that fundamental counting principle. And I need to know, first of all, when do I use it? Okay, and you use it when order is important. That's the big key. All right, so an ordered arrangement. So for example, if you look at this, it says I want to choose 4 people to fill the SRC positions from 12 candidates. Okay, so here's what's the first question you always have to ask is order important? So for enter C positions, we have the president, we have the vice president, we have the treasurer, and we have the secretary. Okay. Now those positions are different positions. So I could put a person as the president, and I could put a person as the vice president, and that would be two different arrangements because the person being the president or being the vice president, order matters. If I just said I want to pick 4 people from 12, I just want a group of 4 people, then it doesn't matter whether I'm selected first, second, third, or fourth. If I'm part of the group, then I'm part of the group. And so order doesn't matter, and that is a combination. We'll talk about that in another video, but a permutation, order is important. Once you've decided that order is important, because these positions are distinct, then the answer just becomes this. You have 12 people to pick from. You have 4 positions you want to fill. So it's 12 permute 4. That gives you 12 factorial over 12 minus 4 factorial, which works down to 12 factorial over 8 factorial. And again, if you write out 12 factorial, it's 12 times 11 times 10 times 9 times 8 factorial, because 8 factorial is the 8, 7, 6, 5, 4, 3, 2, 1. Those cancel, and you end up with 11,880, right? Which is the same as if we just said we have 12 for the first position, 11 for the second, 10 for the third, and 9 for the fourth. So I'm going to let you work on a couple of exercises with permutations, and then we'll start another video that has to do with combinations.